Hi there, my grade 11 chemistry students. Today we're going to be doing a video lesson on solution stoichiometry. As I've been telling you all along, stoichiometry is one of the most important parts of chemistry and study of chemical reactions. So we've done the mass stoichiometry. Today we're moving into stoichiometry of solutions, and in the future we're going to be doing stoichiometry of gases. So make sure you get a good handle on this one. With no further ado, here we go with solution stoichiometry. Now, before we get right down to business with solution stoichiometry, we need to just kind of check ourselves and review a little bit. These types of problems require a few skills that we've talked about earlier in the year, and I just want to go over those a little bit. So we must be skilled at finding the number of moles from a given mass of a solid chemical, and we've done a lot of examples of those through the year so far. We also now need to be able to take information about a solution's volume and concentration to again find the number of moles in that solution. We need to be able to find stoichiometric ratios from a chemical equation and use them to find the number of moles of a product or reactant, etc., from a chemical equation. We need to take an amount of a chemical in moles and then convert that back into either a volume or a concentration of a solution. Okay, so these are some key skills which hopefully you've developed some success at. So are you ready? Well, let's see. Let's just do a little bit of review here. So how many moles of barium chloride, for example, will you find in a 300 milliliter solution of barium chloride with a concentration of 3 moles per liter? Hopefully you remember that the equation we want to use here is moles is equal to concentration times volume. And so you should be getting here 3 moles per liter, right? 3 moles per liter is the concentration of the solution times the volume, and the volume is going to be 300 milliliters. But we won't just leave it like 300 milliliters. We're going to multiply by 1 liter over 1,000 liter because we need 1,000 milliliters because we need to have that that volume in liters. So 3 moles per liter times 0.3 liters is going to give us 0.9 moles. Okay, so that's one skill you need to be pretty comfortable with. Also, moving forward, we need to be able to do these types of problems. Given the following chemical reaction, what number of moles of water will be yielded when 4 moles of methane react with excess oxygen? So there's our methane, there's our water. How many moles of water will be produced here? Okay, so number of moles of water is going to be equal to our 4 moles of methane times the stoichiometric ratios of water, stoichiometric ratio of water over methane, so that's going to be 4 over 2, which is basically a ratio of 2, so that's going to be 8 moles of water are yielded. Okay, so hopefully you're pretty good with doing those types of problems by now. So if magnesium carbonate and sulfuric acid are added together in a beaker and produce 8 moles of magnesium sulfate, as shown in the equation below, and the final volume of the solution is 2.5 liters, what will be the concentration of the magnesium sulfate? Okay, so here's the equation, and as you can see, magnesium sulfate is one of the products. They tell us that 8 moles of the magnesium sulfate is produced. The final volume of the solution is 2.5 liters. So quite simply, in order to find the concentration here, C is equal to N over V. And the number of moles we had produced of magnesium sulfate was 8. So 8 moles divided by the final volume of the solution was 2.5 liters. So throw that into your calculator, you should get 3.2 moles per liter. Okay, that's the answer to the first question there. question 2 here. If the same materials were added together in a new beaker to make 8 moles of magnesium sulfate again, and the concentration of the solution was 0.35 moles per liter, what is the volume of that solution that was created? Okay, so we're going to use the same equation again. C is equal to N over V, but we're solving for V. V is equal to N over C. And in this case, we have, again, 8 moles of material that are produced. And instead of volume, this time we're given concentration, 0.35 moles per liter. So let's just substitute those in. Volume is going to be 8 moles. Concentration is 0.35 mole per liter. Okay, and put that into your calculator. You should find that you end up with 23 liters. 23 liters will give you that concentration with that number of moles. Okay, so that kind of finishes up the skills that you need to have going into solution stoichiometry.